a specific standard which is used for 8051 serial communication, that is called RS232 standard. Okay, this RS232 standard is the communication protocol between two devices, that is between the transmitter and the receiver. So we have different terminologies for this transmitter and receiver. However, before going to that, something basics about this RS232 standard we will discuss here now. As it is mentioned, RS232 allows the compatibility among the data communication equipment. Okay, when you say data communication equipment, your computer is a data communication equipment. Okay, your modem is a data communication equipment. Okay, so how to make this compatible? How this modem and the computer can be connected together? So what is the compatibility, and how do we achieve the compatibility in the sense like you are already familiar that uh, suppose if you have in your DSD lab and all, you were able to directly connect output of one of your IC to the other output of the other IC. That is because both the ICs are compatible. Whereas compatible with the voltage level. So suppose one IC, the first IC's output is high, and high you are representing by a plus 5 volt. The second IC, the input high also will be referred to as a 5 volt. So that means a 5 to 5, if you are connecting, then both will consider this as a 1. So that way, like, there is a compatibility. That is called the TTL logic or the CMOS logic and all, what we will be using in the normal IC terminology. However, in the data communication, we do not have that kind of a direct compatibility when it comes to RS232 standard. That is why. That is because most of the serial data communications protocols were derived much before the emergence of the TTL logic. So, uh, since currently the TTL and CMOS logics are widely used, in order to make this TTL and CMOS logic to be compatible with the RS232 logic, we will be using certain thing called line converters, something like that. So, okay. However, what is the difference? I will tell you in RS232 and normal TTL logic. You know that in normal TTL logic, a 0 is represented somewhere near ground and a high is represented somewhere above 4 volt, like around 5 volt. That is how a 0 and 1 is represented. But look at this RS232 standard. In this RS232 standard, a 1 is represented by a voltage level between -3 and -25 volt. It's quite unusual, right? A 1 is represented between -3 volt to -25 volt, whereas a 0 is represented by +3 to +25 volt. Okay, so this is how a 1 and 0 is represented. 1 is anything between -3 and -25. 0 means between +3 and +25. Okay, this is how a 0 and 1 is represented in RS232 protocol, and anything between -3 and +3 is undefined. It will not be considered either as 0 or as 1, so it is undefined. Okay, now you know that the microcontroller what you are using, the microcontroller uses the TTL logic. TTL logic means for a microcontroller, 1 is represented by a 5 volt. I mean, I'm telling an approximate, not X. There is a range actually, 3.7 volt above. That's a 5 volt is the 1 for microcontroller. And a 0 is represented in a microcontroller by 0 volt or a ground, right? So this is for microcontroller, whereas this is for the RS232 compatible device. Okay, RS232 compatible device. So you see here, there is a total difference between. So now if I am sending a 1 from an RS232 device, it will never considered as a 1 for a microcontroller. Similarly, if I send a 0 from an RS232 compatible device, that will also never considered as a 0 in the this one, the microcontroller device. So this is the main problem. Okay, so in order to make sure that you are having a compatibility between this RS232 and the TTL logic, we will be using something called line drivers. That means a signal will be converted as 1 will be converted from -25 to -3 that value will be converted to plus 5, and minus 3 to plus 25 will be converted to 0. So this line driver will take care of this, and we have an IC to perform this task. This IC, generally what we'll be using is the IC is called a Max 232 IC. This is IC from Maxim. Maxim is the company name. Okay, so we will use this IC. So we will see all these details. We will see all this in detail. Okay, so these are the main things you must remember. That is, RS232 is not TTL compatible. Here the 1 and 0 is represented by a totally different voltage levels, which is totally incompatible with the TTL logics, and we will be using a line driver for making the compatibility possible. So this is about the basics of the RS232 standard. So here we will now see some terms here. So I told you that there are a transmitter, there are a receiver in any communication channel. So when you talk about a transmitter or a receiver, the terminology is what we will be using here is the data terminal equipment, DTE, and data communication equipment, DCE. These are the two terminologies we'll be using. This is like either like a transmitting device or a receiving device in both the way. Okay. So the data terminal equipment is generally like, if you take the, see, like if you have a computer and it is connected to a modem which is connected to an internet. Okay, so if you see that this computer is a data terminal equipment, whereas this modem is a data communication equipment. Okay, so the modem is an interface between the computer and the other devices, other computers around the world, or other modems around the world. So we will take that example. So there is a computer that is a data terminal equipment, and there is a modem which is the data communication equipment. Okay, data communication equipment, DCE. Okay, now the very simple communication between two devices, the very simple communication protocol between two devices is called the null modem connection. Okay, what do you mean by null modem connection? Okay, that is where when you don't have when you connect directly, when you directly connect the transmitter and the receiver part of two data terminal equipments in a cross connection form. So in this format, when you do this, this is called the null modem connections. Okay, so this is about the data communication equipment. So what are the port available in order to make this data communication possible? What are the possible ports? Okay, so the ports available here is DB9. Okay, DB9 is the pin available here to do this process. Okay, so let us understand what is this DB9 ports. What is that sound there? Let's go there. Tell her to come here, Queen, without making noise. Okay, open, close this thing. Sorry for this delay. So we were talking about this DB9 connector. So as I told you that DB9 connector is the port available for communicating the computer to a data communication equipment like modem. So nowadays it is you can see, you may not be able to see in the current computers this kind of DB9 serial ports, but if you have slightly old computers, behind the computer you can just observe there is a connector which is exactly of this same shape, DB9 shape. Okay, this is a 9-pin connector, that is why it is called D-type and a 9-pin connector. And this 9 pins are mentioned here. It starts from where this, if you take this pin facing towards you, it's a male pin or a female pin, you face towards you, and keeping the 5 pins on the top and 4 pins on the bottom, if you face like that, then from the left side when you start counting from top. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is how the numbering of the 9-pin connector, and each pin has got a specific purpose in this DB9 connector. That is, the pin number 1 is called the data carrier detect. So I will explain what are this all these 9 pins separately. Quickly I will explain that also. But anyway, remember that data carrier detects is pin number 1, and receive data and transmit data, pin number 2 and 3. Data terminal ready, DTR, signal ground, and data set ready, request to send, clear to send, and ring indicator. These are the 9 pins. So in this 9-pin connector, if you see, the data will be transmitted. The real data is transmitted between these 2 pins, that is RxD and TxD. So this is the real data where it is available. All the remaining things are either this is basically the signal ground, and remaining things are basically the control signals which is used for communicating handshaking. Basically these are called handshake signals, basically to do the communication between the DCE and DTE, I mean data terminal equipment and data communication equipment. Okay, so the actual data will be between RxD and TxD. Okay, that is why you say in null modem connection we will never use any of these things. In null modem connection, if you see the null modem connection, if you see, it's only between TxD to RxD. So TxD is there, RxD is there, so, and the communication is between these two. This is about the null modem connection. So remaining all are idle in the null modem connection. So this is about the DB9 connector. Okay, so we will see this details of what are these pins does. But before that, remember in this particular topic, that is in this serial communication topics, what are the main important topics which you might expect for the question examinations? All those things are, one is that what is RS232 protocol. Okay, the second thing is explain about DB9 connector. The third thing is what is the line driver, or what is the functionality of MAX232 IC. And the fourth and the most important thing is how to write a program to communicate or to send and receive a data serial. That will be a sure short question, but remaining things could be one of this will be definitely asking. So about the RS232 standards I have explained. About the RS232 standards I have explained, and we have also connected. We have also understood what is null modem connection, and also we have seen what is DB9 connector. So if you see this diagram, we have a data terminal equipment. So the data terminal equipment, what is depicted here, assume that it's a computer in our explanation, and we have a data communication equipment, that is the modem. Okay, so we have this data terminal equipment and a data communication equipment. Now what is DTR? So DTR is when the terminal is turned on. Okay, when the terminal is turned on, it sends out the DTR signals to indicate that it is ready for communication. Okay, it is just the beginning of everything. Beginning of everything. That means if in our example, when the computer is turned on, okay, when the computer is turned on, this particular signal will tell to the data communicate. That means DTE will tell to the DCE that yes, computer is ready to communicate. So that that handshaking it will do. It will say like, yes, hi, I am ready, something like that. Okay, so computer will say yes, I am ready to communicate. Okay, now what next step? In the next step, the data set ready signal or that pin, DTR will tell the computer will tell the modem, yes, I am ready to communicate through DTR signal. And DSR signal is the reply from the modem to the computer. So what modem will say, or what DC will say, that yes, I am also ready to communicate. Yes, you are ready to communicate, I am ready to communicate. That's what. Okay, so it will, this DTR, this modem will send a signal back to computer or a DTE, yes, I am also ready to communicate. So these two handshaking signals is done in the first place. So first thing is computer will send a signal to modem stating that I am ready. Okay, then modem will send signal back to the computer stating that yes, I am also ready. So both are ready by these two asserting these two signals. So then the next step is request to send. Okay, so this suppose once the computer is ready, once the computer is ready and it is ready to send, but the data may not be available at that point of time. So that if whenever the data is available, okay, or this computer has a particular data or particular byte which is about to transmit, okay, the data is about to transmit, that time this RTS, request to send, will be enabled. Okay, so that means that's a third step. So if you see here, these two steps are done. Third steps, this computer will tell a signal, computer will tell a send a signal to modem stating that yes, there is a byte available with me, okay, to be sent to you, to the modem. So that is what the RTS signal does. Okay, then what naturally CTS signal will do? CTL signal will say, I mean, that is clear to send. Okay, request to send is RTS. Clear to send means it is giving a clearance. Yes, this modem is giving a clearance. Yes, you can send a data byte now itself, because if the computer is sending this data to this modem, and suppose once this data is being sent to the modem must save it somewhere, right? But if that saving location is not free, then this data will be lost. So the CTS signal will be only high provided all these saving locations are available, all those things. That means it is clear, our side is clear, you can send your data. So that is the CTS signal does. So this is the four major steps in the data communication, and once this is done, then the data will be transmitted through TXD and RXD. And the other two signals are DCD and RA, which is used when it comes to multiple communication between different modems and all. So if a valid carrier, suppose this modem is detecting a carrier through some other modem or a computer or something like that, then this will send to then the modem will send this DCD signal to the computer. Similarly, the modem generally will be having some more functionalities, like the modem will be connected to a normal telephone also. So in such cases, the modem will be having a telephone will be ringing, and such indication also will be sent to the computer through RI. Okay, this is like little old technology. So, but since still we will be using this. But remember that in most of our communication between the 8051 and any other serial device, we generally need not worry about all these signals, because we will go with only null modem connection. That means we will be only talking about RXD and TXD signals. Okay, so these are the so all the how many pins I have explained here? 1, 2, 3, 4, 5, 6 pins I have explained here. What is pending is that's all the explanation of these pins. And what is pending is, so DCD, data carrier detect, we have seen. Second last one, receive and transmitter is what did I did not explain there, because this is nothing but the data itself. Okay, so there is no need of explaining data. This is over, this is over, this is over, this is over, this is over. So, and one is a signal ground. That means all the pins are explained. Okay, now we will go to the RS232 connection, how the connection is being established between a microcontroller and any RS232 compatible device. So we were talking about the connection to RS232, right? You know that this PC computer is a TTL logic device, whereas it's not like that. A computer is a TTL logic device, but the RS232 pin of the computer is or the DB9 pin behind the computer is a RS232 logic. Okay. So DB9 pin behind the computer is an RS232 logic, whereas your microcontroller is a TTL logic. That means you know the incompatibility issue, right? What is incompatibility? Because here a 1 is represented by voltage range between -3 to -25, and a 0 is represented between the voltage range 3 to 25. This is the voltage levels of 1 and 0, whereas here 1 is represented by a 5 volt and 0 is represented by 0 volt. So there is an incompatibility here, right? So the connection between a computer RS232 port and the microcontroller cannot be directly established. That means we cannot directly connect a wire from this TXD pin. This is a DB9 pin, right? So in the DB9 pin, pin number 2 and 3 are TXD and RXD. So we cannot directly connect this TXD and RXD to the microcontroller TXD and RXD. There must be something in between. So this is the issue, okay? And for the microcontroller, if you see, there also we have a TXD and RXD. And you see that in the microcontroller pin diagram, if you see, the pin number P3.0 is the transmitter and the P3.1 is the receiver for a microcontroller. So we see that both for the PC side, there is TXD RXD. For the microcontroller also, there is TXD RXD. Okay. So how do we do this connection? That is about the that is what we are going to see now. This is whatever I have explained here, I have given here. So look here, you see the right side part. Okay, we have a DB9 connector. This is the DB9 connector, and this comes behind the PC. Okay, DB9 connector will come behind the PC, and we have a microcontroller 8051. Okay, so for this DB9 connector behind the PC, we have a transmitter as well as a receiver. So what is pin number 3? Pin number 3 for DB9 is, if you see the pin number 3 is transmit and 2 is receive. So you see here 2 is receive, 3 is transmit, right? So we will write it here. Two is RXD and 3 is TXD. 3 is transmit, 2 is receive. So this is about the DB9 pin which is there in the PC side. So let us think about only this much portion. And for the transmitter, for the 8051, we have TXD and RXD as pin 3.0, okay, and 3.1. Now what is our aim is, I need to connect this pin, transmitter pin to, this will transmit and this will receive. The connection has to be between TXD to RXD. Similarly, this will transmit and this will receive. So that is what is called null modem connection, is it? Okay, but you know, because the PC side, the 1 and 0 voltage levels are different, and 8051 1 and 0 voltage levels are different. So we cannot directly connect as we have shown with this red line. We cannot directly connect. So what we will be doing is, we will use an IC called MAX232 IC. Okay, this MAX232 IC is nothing, a line driver, or it will convert. Okay, if you see here, this MAX232 IC will convert if the voltage levels at the input of the MAX232, if it is between -3 to -25, it will give a 5 volt at the output. If the input voltage is between 3 to 25, it will give an output of 0. So that's a level converter, we will say. So this is the MAX232 IC does. And in detail, how this, what is the content of this MAX232 IC, we will see in tomorrow's class. So with this basic idea about why we need a MAX232, and why can't we connect, instead of having an intermediate guy like this, Why can't we connect this PC side to the microcontroller? All these things we have seen in this diagram here.